Welcome to EDU World Space.
So if we want to try to find the arc length of the intersection that is formed, we first need to come up with some parameterization for this curve. Now over here, since we have an oval, I would think that would be the easier place to start. So the parameterization that would work is cosine of theta, and y is equal to 2 sine of theta. And if you were to take cosine, plug it in, 2 sine theta, plug it in, you'll see we get 4 cosine squared plus 4 sine squared. And then cosine squared plus sine squared is just going to be 1, so then it's 4 times 1. So it is equal to 4. Now what we're going to do is take this and plug it in over here. So this should give us cosine theta plus, and actually I'm just going to subtract x and y over. I'll do that first. It would be z is equal to 2 minus x minus y. So then z is 2 minus cosine theta minus 2 sine theta. So for our parameterization, this is going to be r theta, and I guess you could use t as well, but I guess I'm just used to writing theta anytime I have like sine or cosine pop up. It would be cosine theta 2 sine theta, and then 2 minus cosine theta minus 2 sine theta. Okay, and now if we want to figure out what our values are going to be for going all the way around, what I would do is go ahead and just use t is equal to 0 to start. So that would give us r of 0. So that's going to be 1, and then that would be 0, and then here this would be, so 2 minus 1, so that would be 1, and then minus 0, so that would just be 1. And we want to figure out, okay, well, where would this occur again? Well, the next time that cosine is 1 is at r of 2 pi. So let's just plug 2 pi in and make sure that we get the same point. So this is going to be 1, sine of 2 pi is still 0, and then this would still be 2 minus 1 minus 0, so yeah. So we can use these for our a and b. All right, so now let me write out what the arc length formula is again. So arc length, remember, is equal to the integral from a to b of the magnitude of our derivative, and we integrate that with respect to t. Well, I guess in this case it would be a theta, not t. And that would be r prime t. So r prime is going to be, well, we just take the derivative component-wise. So cosine becomes negative sine, sine becomes cosine, and then this would be 2, or the derivative of that is 0. The derivative of cosine is negative sine, so that would be just sine of theta, and then that would just be minus 2 cosine of theta. Right. And now remember, our magnitude is just going to be where we square all of these. So let's go ahead and do that. So this would be the integral from 0 to 2 pi of, so sine squared theta plus 4 cosine squared theta, and then plus sine theta minus 2 cosine theta squared, all square rooted, d theta. And then let's go ahead and see if we can simplify this at all. So we have sine squared theta plus 4 cosine squared theta. Expanding that out is going to give us plus sine squared theta, and then minus 4 cosine theta sine theta, and then plus 2 cosine squared theta. Oh, not 2, 4 cosine squared theta, and then we can go ahead and combine all of our like terms. So that would be 2 sine squared theta, and then we'll have minus 4 cosine theta sine theta, and then plus 8 cosine squared theta square rooted. Okay. And I don't necessarily know how to integrate this, because the only thing we could really possibly do is hope this is like a perfect square or something. But I don't think we can turn this into a perfect square. Yeah. So the only other thing I could really think of is just using like a Riemann sum to approximate this, or if you just have like a calculator, you can just go ahead and plug that in and go from there. So if you don't have a graphing calculator, that will do it. A website that I normally use is Integral Calculator. You can just see the URL up top there. And you can see here I have it plugged in, and you have to kind of plug it into like this form here, and then to get the bounds, normally these are going to be blank over here, and then you would just come over here and click on that, and then this sidebar pops up, and then you can just do 2 pi. Oh, and as you can also see here, I'm using x's as opposed to theta, but you can change it to be whatever variable you want. I just left it as x because that's easier to type. But now let's go ahead and scroll down. Yeah, and here you can even see that this is saying they have no idea how to integrate this either. So this down here is the approximation that they give us. So they wanted us to round to 4 decimal places. So you would just round it up. So it would be 13.5191. So now this is going to be approximately 13 point, what was it again? 5191. Yeah. Unfortunately, we really can't evaluate this integral outside of just using a Riemann sum, or just plugging it into some calculator, but I think that's all we can really do in this case, since most integrals you can't actually integrate anyways.